Hi students, welcome to today's class. Today I am also going to explain definite integrals. Now I am going to start the problems. Okay. In the previous class I explained about some limit of a sum problem, how to convert limit of a sum problem into a definite integration. Okay, but how to solve the problems of definite integration? Okay, to solve, first of all we should know basic fundamental concepts in definite integrals. So we have some properties. So I have written some properties here. So see the first property, we define b to a f of x dx is the negative of a to b f of x dx. That means here a to b f of x dx is minus of b to a f of x dx. As I already told you that this is called lower limit and it is called upper limit of the integrand f of x variable of integration x. Okay, now here the thing is f should be integrable in the closed bracket a to b. The first thing, whether it is a it should be understood that whenever you are writing here b to a or a to b, then the function should be integrable in the domain a comma b. So that means here the lower limit is a, here the upper limit is b, f of x dx. So if you want to change into lower to upper and upper to lower, this you have to write down minus. So that means whenever if you get like this type of term, so this is equal from 0 to minus 1 f of x dx, it is same as minus 1 to 0 f of x dx. This is a lower limit, upper limit. You change it into upper to lower, lower to upper, then you have to write down minus. Okay, now right. So I hope that you understand this point. Now coming to here the function f is integrable in the domain a comma b. Okay, now let us take c is a point belongs to the interval a to b, then the integrable from c to c f of x dx is equal to 0. So here lower limit is 0, upper limit is also 0. That means if you come across wherever some pi by 2 to pi by 2, some x square plus 4x plus 3 dx, so then you can write down simply 0. Why? Because their upper limit and lower limit both are same. Okay, right. So these are called algebraic properties. The first property is from integral a to b, f of x plus g of x is equal to integral a to b f of x dx plus a to b g of x dx. Okay, now so this is called algebraic property. But the thing is here f is integrable in a comma b, g should be integrable in a comma b, f plus g also should be integrable in a comma b. F plus g also should be integrable in the domain a comma b. Okay, now then only this property applies. If it is here plus, here write down plus. If it is minus, here also minus. Okay, that means you can separate, just like a limits we separated and derivatives also we separated, indefinite integration also we separated, like that definite integration also we separated. The condition is f is integrable, g should be integrable, and f plus g and f minus g also should be integrable in the interval a comma b, then only this property applies. Okay, now coming to second next property, here integral a to b kf function, here k is a real number, k is a real number, then you can take k outside of the integral. So k into a to b f of x dx. But the condition is here f is integrable in a and b, therefore kf, the function kf also should be integrable in a comma b. The function kf is also integrable in the closed interval a comma b, then only this property applies. That means what? You can take the k common outside. For example, if you want to integral 0 to pi by 2, 5 sin x dx, then you can take 5 common outside, 5 sin x dx. Understand? 0 to pi by 2 sin x dx. Therefore, you can take constant outside. Okay now? Right. I hope that you understand these 4 properties. Now, I am going to explain a very, very important property. So, generally students, they will misunderstood this property. I explain that. Okay now? Welcome to this property. So, very, very important property. So, the property is integral a to b f of x dx is equal to integral a to c f of x dx plus integral c to b f of x dx. Generally, students, they think that this point C should belongs to closure bracket a comma b. The point C belongs to closure bracket a comma b. But so remember that even though C does not belongs to a comma b, if C is outside of a comma b, then also this formula workouts. Be remember that a to b, a to c, c to b. Generally, students think that C belongs to closed bracket a comma b, even though C does not belongs to closed bracket a comma b. If it is outside, then the formula will be worked out. Okay, I will show using one small example. For example, see here integral 0 to 1 x dx. Okay, now. So, what is your interval in which the function x is defined? 0 to 1. Yes, in 0 to 1 the function x is defined. That means you can get the images. This I am writing as 0 to 2 f of x dx. F of x means x dx plus 2 to 1 x dx. Or both are same? Both are same. Let us check here. But if you observe here, 2 does not belongs to closure bracket 0 to 1 clearly. So, 2 lies outside of the 0 comma 1. Right. Then let us check the answer. So, what is the integral of x here? As we know the formulas, in the indefinite integration, integral of x is equal to how much? Already we learned that x square upon 2 upper limit, lower limit. So, this is a upper limit 1 by 2, lower limit as usual we will get 0. So, 1 square 1 by 2 1. Let us check here. So, this is a x square by 2 upper limit, lower limit. This is also x square by 2 upper limit, lower limit. What is upper limit here? 2 square 4, 4 by 2 2 minus 0 lower limit. Here how much here? Upper limit 1 square 1 by 2 minus 2 square 4 by 2 2. So, if you observe here plus 2 minus 2 cancel, 1 by 2 is equal to 1 by 2. Got it or not? Yes. That means this 2, even though it does not belongs to 0 to 1, whatever may be the interval from A to B, then the formula also work out. So, here onwards you can take this C, whatever may be that point, whatever may be the interval, you can take the ultimate answer is correct. Okay, na? I hope that you understand this point. So, let us go for next point. Welcome to next property. So, very easy property, integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Okay, now. So, these are all properties have proofs also they have. Okay, now. But in the JEE mains point of view, if you learn the proof also, that will be remembered forever. So, that will be remembered forever. So, for this I am explaining the proof of this function, okay na? Proof of this theorem. Let us see that. First let here whatever may be that, here what f of a minus x, no, whatever may be that, let a minus x is equal to t. Put a minus x is equal to t, substitution method. So, this is equal to minus dx is equal to dt. This implies dx is equal to minus dt. Now, let us take right hand side part. What is the right hand side part? Integral 0 to a f of a minus x dx. This is whenever we do substitution, according to that the limits are also will change. Here what is the lower limit? 0. So, it substitute x is equal to 0 here, then t is equal to how much? A. So, lower limit is a. Upper limit is what? A. Substitute x is equal to a. So, why? Because this here variable of integration is x. That's why this interval belongs to x. Understand? Substitute x is equal to a minus a, 0. That means it is 0. So this is f of a minus x is equal to how much? T. So this is dx is equal to how much? Minus dt. Okay now? Then you can take minus dt means what? Minus 1 into dt. That means minus 1 you can take common outside. Here minus will become a to g will be a to 0 will become 0 to a. So this is a 0 to a f of t dt. Okay now. So if you observe already, we know the problem. In the indefinite integration, we know that property integral of f of x dx is same as integral of f of y dy is same as integral of f of t dt. Why? Because it is at x, y, t, whatever may be there, they are just dummy variables. Okay now, we can take any variable x, y, z, whatever may be that. So this is same as 0 to a f of x dx. So very easy proof for this. Generally students, they won't learn this proof. They won't learn this proof. But if you learn this proof, it will be remembered very easily. Those who are preparing from long-term batches, that means those who are preparing from 11th class onwards for JEE mains seriously, they should learn the proofs also, so that it enhances your mathematical skills and you never forget this proof. Okay na? So using this, as sir we learned this, using this what is the conclusion we can get. So using this we are going to get a very good number of results we are going to get. Let us see that results. Okay, welcome back. So let us see one result, that the result is integral 0 to pi by 2 f of sin x dx. That means here the lower limit is 0, upper limit is pi by 2. There is a function in sin x. There is a function in sin x, completely sin x. Then this can be written as integral 0 to pi by 2 f of cos x dx. F of cos x dx. Sir, what is this, sir? For example, you tell me any example. For example, if it is 0 to pi by 2, if it is sin square x minus 2 sin x plus 1 is there, this can be written as integral 0 to pi by 2 cos square x minus 2 cos x plus 1 dx. That means sin x you can change into cos x and cos x you can change into sin x. Understand this? Okay. So same property, there is one more property, 0 to pi by 2. So f of tan x dx is same as 0 to pi by 2 f of cot x dx. Okay now, in place of x substitute pi by 2 minus x, then tan x will become cot x will become tan x. Same logic applies here. Understand? The next one is integral 0 to pi by 2 f of cosecant x dx is same as integral 0 to pi by 2 f of secant x dx. Cosecant x will become secant x and secant x will become cosecant x. But here the rule should be, here the condition should be, lower limit should be 0, upper limit should be pi by 2. Then only these results will valid. Otherwise, they won't valid. Okay na? And one more thing is integral 0 to pi by 2 f of sin 2x cos x dx is same as integral 0 to pi by 2 f of cos 2x sin x dx. Understand this? Okay. So this is also a very useful formula. Sin 2x will become cos 2x, cos x will become sin x, like that. So whenever if you remember these results while doing the problems, you can convert this to this form to this form. Okay na? Right. I hope that you understand this property. So let us see one more property. If it is 0 to a, no, if it is a to b, let us see what happens. Welcome to the next property. So the property is this: integral a to b f of x dx is equal to a to b f of a plus b minus x dx. That means a plus b minus x dx. Both these integrals are equal. So let us see the proof of this. Okay. So whatever may be that right hand side, you concentrate on right hand side. All these properties, we prove that right hand side is equal to left hand side. That will be very easy. Whatever may be this here, put it as plus minus x is equal to t. Whatever may be that a plus b minus x, put it as t. So this implies minus dx is equal to dt. That implies dx is equal to minus dt. Why? Because here a is a constant, b is also a constant. Then your right hand side will become, so here a to b, no, now will automatically the limits are also will change. So when x is equal to a, substitute x is equal to a. If you substitute x is equal to a will cancel, you will get b. Upper limit b, substitute in place of b, plus b minus b will be cancelled, upper limit will be a. This is equal to f of a plus b minus x value is how much? T into dx value is how much? Minus dt. Yes, automatically this minus is there. B to a will become a to b. F of t dt we can write down f of x dx. Therefore, a to b f of x dx. Understand this? So, therefore, integral a to b f of a plus b minus x dx is same as a to b f of x dx. Okay. So, very nice problem. Using this, what are the very important deduction is there? Important deduction. What is that important deduction is? Integral a to b f of a plus b minus x by f of a plus b minus x plus f of x dx is same as integral of, it is same as integral of a to b f of x by f of a plus b minus x plus f of x dx. This is equal to 1 by 2 b minus a. So, this is a one of the very important deduction. So, here denominator is same amma, f of a plus b minus x plus f of x. Here also f of a plus b minus x f of x. Therefore, here numerator f of a plus b minus x, here f of x is there. Okay, now. So, if you add the both are the integrals are same and it is equal to 1 by 2 b minus a. So, you can get problems from these properties. We remember this property, you can directly write the formula 1 by 2 b minus a. Okay, now, right? Very important deduction this is. You can prove it, we can prove it this deduction. Okay, right? So, next let us see the next property. Dear students, let us see one more very important property. So, the property is, if minus a to a, integral of minus a to a f of x dx is equal to 2 times integral 0 to a f of x dx if f is even function, simply 0 if f is odd function. This is a well known thing. So, the condition is minus a to a f of x dx, it is same as if the function whatever may be the integrand, if it is an even function, the answer is 2 times 0 to a f of x dx. If this integrand f of x is happens to be an odd function, the simply the this definite integral value is 0. So, what is the proof of these theorems are very easy. So, let us learn the proofs also. Let us learn the proofs. So, here let us write down minus a to a f of x dx is same as minus a to 0 f of x dx plus 0 to a f of x dx. Okay, now can I write it as already we have seen one property, a to b means, so a to c, c to b, we can write it as I write. So, that means 0 belongs to minus a to a, 0 belongs to. May belongs to, may does not belong to, we can separate, no problem. Now, see this value, okay na, right. So, let us take, let x is equal to minus t, substitute, x is equal to minus t, substitute. Let us see what happens. So, this is equal to dx is equal to minus dt, dx is equal to minus dt. Now, I am concentrating on this. integral minus a to 0 f of x dx. This is equal to integral. If your x value is minus a, minus minus will cancel, t is equal to a. Okay. If your x value is 0, then t is also 0. F of your x value is minus t into your dx value is minus dt, right, minus dt. See here f of minus t, you should not take minus common outside. Here you can take minus, here minus 1. Then a to 0 will become 0 to a. This is 0 to a f of minus t dt. Here t is just a dummy variable. So therefore you can write it as 0 to a f of minus x dx. Okay now. So in place of minus a to 0 f of x dx, you can write it as 0 to a f of minus x dx. Okay, let us write it. So here minus a to a f of x dx is same as, right, 0 to a f of minus x. Here it is also 0 to a, both low, but for both the integrals lower limits are same, upper limits are also same. Therefore we can both combine together. So this is a f of minus x plus this is f of x dx. Okay now, right. So total minus a to a f of x dx is equal to 0 to a f of minus x plus f of x dx. Okay, right. Now coming to the definition of even function, odd function. Even function means what? F of minus x is equal to f of x. Odd function, that means what? F of minus x is equal to minus f of x. That is odd function. If it is even function, in place of f of minus x, you can write it as f of x. That means f of x plus f of x, 2 times f of x, you can take the 2 common outside, 2 times f of x, 2 times f of x, that is f is even function. Okay, if it is odd function, f of minus x is equal to minus f of x. In place of f of minus x, put minus f of x. Minus f of x plus f of x gets cancelled. Integral of 0 is 0 if it is f is odd function. Understand this? So 2 times, of course, here not simply. So 0 to a f of x dx. 0 to a is there. 0 to a f of x, here f of minus x is also f of x plus f of x, 2 times f of x. You can take 2 common outside. 0 to a f of x dx, f is even function. If f of minus x is equal to minus f of x, then this both will get cancelled, then you will get 0. So very, very easy proof this is. So you maintain a separate notebook for all the definite integrals or indefinite integrals proofs. Separate notebook, you hand notebook, you know, prepare. So if you remember these theorems using the proofs are also, then you have a good subject and a good command over the subject. Okay na? So I hope that you understand this property. Let us see one more property. Dear students, welcome to this property. So this property is integral 0 to 2a f of x dx is equal to, if f of 2a minus x is equal to f of x, then this integral value is equal to 2 times 0 to a f of x dx. If f of 2a minus x is equal to minus f of x, this integral value will become 0. Then how to prove this? Okay. So let us prove this theorem, very, very easy theorem. So generally students will by heart this theorem. So if you know the little bit proof also, then you will remember this result forever. Okay, let us see this. First take the left hand side, 2a f of x dx is same as 0 to a f of x dx plus integral a to 2a f of x dx. Okay, right. 0 to 2a f of x dx. Okay now, right. We can write it as 0 to 2a, 0 to a to 2a. We can write it. Right now, let us concentrate on the second derivative. Second integral. In the second integral, put 2a minus x is equal to t. Sir, there is no 2a minus x there, sir. X is there. No, in place of x, you can put 2a minus t. Okay, I will tell afterwards why. So, this implies minus dx is equal to dt. This implies dx is equal to minus dt. With respect to x, I have taken differentiation on both sides. Then your a to 2a f of x dx now is equal to, wherever x is there, lower limit is a, x is equal to a, substitute here a, 2a minus a, t is equal to a, lower limit is a. Upper limit is how much? 2a, substitute 2a here, 2a minus 2a, how much? 0. Upper limit is 0. F of, what is your x value? See here, 2a minus x is equal to t, therefore x is equal to how much? 2a minus t. 2a minus t into, what is your dx value? What is your dx value? So, this is nothing but minus dt. Okay, na? Yes, here minus is there. So, a to 0 will become 0 to a. 0 to a f of 2a minus t dt. Yes, already we told that. So, here t is a dummy variable. You can write it into x. That is equal to integral 0 to a f of 2a minus x dx. In place of t, I changed it into xy because t is a variable, x is also variable. We can change it to any variable, required variable. Now, your problem is 0 to 2a f of x dx is equal to 0 to a f of x. See here, 0 to a. This is nothing but these two are equal. These two are equal. Understand? These two are equal, no? 0 to a. This is also 0 to a, 0 to a f of x. This is f of 2a minus x dx. Okay, now? Right. Since because for both the integrals, lower limits and upper limits both are equal, I wrote it in the same. Now, coming to your problem, coming to here, see here, if f of 2a minus x is equal to f of x, in place of f of 2a minus x, write f of x, in place of f of x, what happens? F of x plus f of x, 2 times f of x, therefore, it will become 2 times 0 to a f of x dx. Okay, now, the first result, we got the first result. Okay, now, if it is f of 2a minus x is equal to f of a minus x means what? 2a minus x plus f of x is equal to how much? 0. If this value, total value is 0, f of 2a minus x plus f of x value is 0, then what will be your answer? Result is the second result will get. Okay, so this is the proof of the second theorem. Okay, now, right. Dear students, I hope that you enjoyed today's class. So, with some more properties and some problems in the tomorrow's class, I will stand before you. Until then, all the best.